We're on site with the Measured podcast at MREC 2025, filming from the RSC booth. A great opportunity to catch up with friends and colleagues, and I roped a few of them into chatting about what they're up to and how they're helping changing the industry. In this chat, I sat down with Bruce Armstrong, Managing Director at Independent Mineral Standards. We talk about the journey of the company that he started from a garage and what motivated him to choose this entrepreneurial pathway. We discuss what makes IMS different and cover some of the technical issues when certifying CRMs, particularly for Photon assaying. Hope you get something out of this chat. Enjoy.
The issue for us as a company is we're doing some really cool stuff.
Yeah.
And barely anyone knows about it.
Right.
And so actually communicating with the geologists.
Yeah.
So we've got our core kind of clients and we do some really cool stuff with them.
Yeah.
And then you start talking to people in the gold space, because a lot of our basis has come from iron ore and bauxite and so on like that.
Right.
And then you talk to the gold people and they go, oh, who the heck are you?
Yeah.
Never heard of you before.
Oh, no, I am a few years ago.
Right.
But you go to conferences for that reason,
Well,
obviously.
we go to conferences, absolutely. So we started it, our story is we started out, actually, you were at that very conference.
The mining geology,
No, it was a sampling 2014.
Oh, that's a long time ago.
Right,
Yeah.
So the story how we started was me and Timon, the other director, we started the business and we fell into it.
Yeah.
We actually bought some equipment, second-hand equipment, and it was stored at the back of a guy's shed.
Was it a garage? Yeah, right.
Yeah, it's his garage, right? We had
Cool.
to go and pick it up from his garage, moving the car out and all the rest.
That's awesome.
To get the second-hand rotary sample dividers.
Yeah.
And we had no idea how to use this stuff. And it was just there's two guys that were, shall we say, in the dips of the ups and downs of the mining industry. We were in the down phase.
Yeah, I know those. I remember those years. Yeah.
Right, so I was the start-home dad.
Yeah.
I was daddy daycare. The kids are off to primary, kindy, and pre-primary.
Yeah.
And I had some hours to burn. And it's like, we should start a business.
Yeah.
So
That's where all great ideas are born, right? So that's
right. We got spare time. I got 5 hours a day. I can do something. So we started out doing that.
Good on you, man. I didn't know that. That's a really good story. Yeah.
At the same time, I got very ill.
Oh,
so,
right. That's not so good. Yeah.
So I think the phrase was I was circling the drain.
Right.
And just as we were buying the business, so I spent 6 weeks in hospital.
Right.
With flesh-eating bug. So I got all.
Yeah.
So I came out of that.
Yeah.
And 2 weeks later.
Yeah.
This is a conference.
Yeah.
So I've hobbled up to the conference I'd lost 20 kilos. I was just I was smashed. I was on painkillers.
Yeah.
So but it was just turn up and we'll figure it out. And we got a contract out of that because I was doing the crushed iron ores.
Yeah.
So iron ore industry, they actually test the sample process.
Right. Yeah.
Because a lot of them have got automated sample prep gear. And there's not somebody sitting there going, oh, that doesn't sound right. It's not being monitored. So what they're actually doing is using crushed iron ore standards to actually test that entire process. So that was our start. And
was that a start because from a service perspective that was an actual gap in the market, or is it just because you had some knowledge there that others didn't, or? It's a pretty crowded space still, but there must have been.
No, there was a gap in the market. Gannett Holdings was he was on the retirement curve, and so there's a small little chink of an opening.
Little opening. Yeah.
And so we got to start with that.
Yeah.
And we started out with commercial rotary sample dividers, and then spent a couple of years actually completely redeveloping them.
Right.
So now we can do 20-ton batches of crushed iron ores. So that gives everyone multiple sites, got longevity of supply and things like that. So you can get those control curves going for a long time. And I spent 2 months trying to figure out how to balance an RSD.
Yeah.
I was getting a little high-speed camera out. I was watching this and how it falls and recording weights and times and measures and so on like that.
Yeah.
So
Oh no, we could talk for hours about that. I've got questions there, but that's the amount of time you must have spent doing all of that.
So we've really developed all that gear. It's kind of proprietary gear and the systems how to do that. So now we're at the stage for crushed iron ore reference materials. We're getting the same between unit variances as you're going to get with the pulp.
Okay. Wow.
So 2 kilo minus 5 mil.
Yeah.
So we took that kind of specialty, and then we've gone on to do other like cool stuff.
Yeah.
Like the bauxite guys are very particular about particle size distribution in a CRM because they've got a lot of the partial digest and so on like that. So we sat there and figured out how to do manage the pulverisation process to actually hit their targets that they needed, and then actually homogenise and package it out. That's kind of standard. We've gone on to do pigeon pairs for multiple analytes. So pigeon pairs for a single analyte, really easy.
Yeah.
Right. 3 standard deviations apart. Pick the grade curve for the variance, easy. But when you've got like 20 variables,
that's harder to do. Yeah.
So we've got a client that gives us all RC bags, all with the analysis on there.
Yeah.
So we'll have it like, how many drums was it? 60 drums worth of RC bags.
Yeah.
So you sort them all out mathematically and do the process.
Big spreadsheet. Yeah.
Took us a long time to figure it mathematically how to get these all balanced.
Yeah, right.
Because there's a grade target they want to hit, and then you want three standard deviations for each analyte across there and so on. So we've gone and developed that for a series of pulps for a client.
Nice.
No one else knows about this. This is all off the record as such, because it's a custom job.
Yeah, right.
Never sees a public day of light.
Okay. And then you got into the photon assaying later because it was another gap that you saw, or
okay. So the photon assay, like we had all this specialty or expertise in crushed and handling it.
Yeah.
Because when you go away from cohesive powders and into crushed material, there's a lot of material handling kind of expertise that you need. And so we had that basis. We were looking at gold and going, you know what, sample preps like this magic thing that happens.
Yeah.
You got all the PhDs looking at the chemistry of the analysis, and then the front end of the lab, it's all it's kind of forgotten about. It's the low-paid labour just grinding through it. So we had that in mind. Went, we could do something there, and then John Carter, our GM, came on board, and we're kind of talking through that and going, yeah, we could do something there.
We could do that. Okay.
And that coincided with both photon assay and PAL kind of coming into the prominence. So those large mass analytical methods where they're testing a crushed product like minus 3 or 5 mil or whatever they're doing. Yeah. So happy coincidence.
Trying to grow a company myself, it's always difficult to make these strategic decisions, and you watch what your competitors are doing, right? Because you're providing a product, so you can actually see what others are doing around you. Is there a strategic decision, or that on Monday you have a chat and you said, let's go and do this thing, or is there a broader, how do you set your strategy in the space? Do you read? Do you monitor the industry? Do you spend a lot of time figuring out what your competitors are doing to really see where there's an opportunity, or did this kind of sort of fall out of the sky and say, okay, yes, we can do this. Let's have a crack at it? Because
bit of both.
I guess so. It's a probably leading question because we do much the same. It's like, oh yeah, this looks cool. Do we all think this is a good idea? Let's go and do it. So
okay, the industry's changed a fair bit since we started. I think we're second to last one out that's not private equity.
Sure, yeah.
For reference materials.
Which is a good thing probably, right? Because it allows you to, set your own strategies and
absolutely,
react to these opportunities.
We can have fun. Yeah. We can have fun with what we're doing.
Yeah, exactly.
So there's a huge amount of kind of, that looks interesting.
Yeah.
So the other constraint is the capital required to actually go head-to-head with established players. Because it's actually a pretty crowded field in doing gold. Let's say gold, pulverised gold, natural ores.
Yeah.
Some big established players. And so it's like, yeah, we're going to lose that battle if we go head to head with them.
Yeah. Okay. Yeah.
Because
they can just throw so much at it. Yeah.
Well, yeah. There's distribution, there's the capital requirement to actually get
R&D, the marketing that they can
right.
do.
So there's an element of where we're going to spend our efforts on and making products. So we've done stuff that, they do the profitable bit and we do the hard stuff. So some of that, other projects that we haven't even really spoken about here. It's like making XRD standards and so on. That was interesting at the time. We had some people we were working with in the commercial labs that really wanted it.
Yeah.
We haven't made any money from it.
No, it'd be hard to scale that, I reckon. That's, But maybe just from a technical side, right? Because I always try to have a bit of a technical focus, because a lot of people listening will be geologists.
Right.
We've done a couple of things together. We're trying to help people out there with information, and we just had a session on myths yesterday, so you know where I'm going. Throw me a couple of myths that in the space that you're working with that you just want to see dead on the floor forever. Like what are people's misconceptions about the use of the material, the making of the material, the purpose?
There's probably, I don't know about myths, but there's probably education levels, understanding of basic statistics.
Okay.
So all the producers have their own take on what they put on the certificate. So that's, they're not apples with apples in that regards. So confidence limits and how you actually calculate the standard deviations, is it grouped or is it the entire population of standard deviation? There's a lot of kind of people not reading the documents and understanding it. That could do with being educated.
As you were saying that, let me try and phrase this a little bit better. So from a service perspective, if you're selling something that is, when I say selling something, we're selling a service, you're selling a service, software people sell a service, and you want your client to understand exactly what it is that you're selling so that they can see the quality of the product for what it is, right? Because you're selling the product that you're making. It's not because it's in a nice pink bag with a ribbon around it, right? That's not why they're buying your standard. And it's probably mostly to do with cost, and it's probably a lot to do with time. But in a lot of instances in our industry, there are misconceptions about technical standards and quality of the service or of the material that you're selling. And the laboratories have the same problem, right? If I take a classic fire assay process, I mean, there's 100 things that can go wrong. And yes, you can drop that price, but then you have to sacrifice on the quality, right? But the problem, I guess, when I talk to labs about this as well, is that clients don't always understand technically with the finer detail, if you're not a lab person, what that quality really means. So you end up being so focused on the price. Now, I'd imagine that if there are 10 companies providing CRMs, right, and you go and you get a quote for a matrix match CRM for some mine site, right, and you know that your competitors are going to use X labs and they're going to do this at a certain cost that gets that standard out with a certificate, without them necessarily appreciating the uncertainty involved with the data that you've created. So if they don't understand it, then it becomes competitively a really tricky game, because now you have to either lower your standard to match that price, or you got to do better and educate those clients when you send that quote. Do you see where I'm going with this? So I have a real philosophical conundrum with what we do sometimes, and we call it, do we give the clients what we think they need, or what we know we need, or what they want, right? Because those two are different things sometimes, and not to sound all, know it all, but that is a real problem that I can see with people selling a fire assay at a lab, or the Photon assay guys with crystals trying to sell what they do, or what you do if you're competing. So do you feel that at all when you're sending a quote to a group to, do you feel that pressure to kind of, balance that out, or?
Not necessarily price. One of the issues we've got to think about, and it's more of a technical thing, is we can make a really homogeneous pulverised product. And that's just the application of more grinding time. And we'll get that down to minus 20 microns. But that doesn't replicate what happens in the lab.
Exactly right.
So what happens is, you've got this nice, perfectly ground material, and we can classify it at that. But it actually changes the rheological properties. It's a very cohesive powder. How it fuses.
Well, the particle. So sorry to interrupt, but I get that side completely right. You can't make it perfect because routine is not perfect. So you have to test it against a routine. So pulverizing it to 40 just to homogenize it, just to show that it's has this perfect standard deviation isn't necessarily the selling point. What I mean is, for instance, you go to 6 labs as a minimum for your round robin. You go to the ISO 35 guide and you look what's required and you do the minimum. You're going to get 2 labs that are completely out. And then depending on how you calculate that standard deviation, which is something what we talked about before, you can get some pretty wide gates, and at that point it's not fit for purpose anymore, arguably, right? Because now you are really, you can't actually see any signal through the noise because you've allowed 2 labs in there, and effectively what you're doing is you're artificially creating a variance that probably doesn't exist. And this could get quite technical, I guess, but again, particularly in that instance where you need to make a decision, okay, we need to add another 5 or 10 because otherwise this standard is just gonna not be usable. Do you feel any responsibility to manage that process, even though you know that the people you're selling to might not necessarily even want to know this or ask you the question in the first place?
So what happens is you get some clients who want to have a preconceived idea of how many labs they want to see and all these parameters, and then you have others that just leave you to it.
Right.
Now, number of labs.
Yeah.
The issue there is that for some analysis, there's a limited number of labs who are competent in that area. So adding more labs actually detracts from it.
Right.
So iron ore, we get to about 10 labs. Now you start going international, and they're either not used to doing hematite goethite, or they're doing magnetites. It's not their bread and butter job, so they can do it, but the LOIs aren't quite right, and they tend to be outliers. And so adding those extra labs
doesn't actually add value.
Doesn't add value.
Do you say that in the certificate then? Because that's something that I...
No, we just choose how many labs we're going to use based on who we know.
No, I know that, but if I would buy that, and then for the people that think they know what they're talking about, and you would read that, and it's like, oh, there's only 8 that can be good. But if there's a text in the certificate that says, look, we've chosen these labs and not more because of these rough, without pointing any labs out or calling anything out, that would probably be useful for people to see the reasoning behind that, because as you sort of explain it, that makes perfect sense. But people can't always read what they want to read in these certificates either. So,
fair point actually, because where it really counts for a lot of the work we do is custom work.
Right.
So some of these partial digests or really specific analysis is going to. There are actually really limited number of labs in the world that are doing that on a competent in that we know of.
Right.
We've got a list of about 200 labs that we.
And how do you kind of scope that competence? Is that how do you judge that?
We've got a big long list, and we monitor that and ask it. Have conversations with them.
Right. So it's based on interviews and reading their SOPs, professional standards, that sort of stuff. It's not that you run a test, for instance.
No, it's too big a
I know,
scope.
but I'm just clearing that out, right? So if anybody's wanting to know how that works, then So reputation,
trial and error.
Trial and error.
Trial and error. It's empirical testing.
Because I had this conversation, and this is years ago now. I think it was with geostats, and I had no idea what I was talking about, and I was querying why that gold standard had only 6 participating labs, because it wasn't performing. And I rang the guys up and I said, look, I don't understand how this works. Why are there only 6 labs? And they said, and I'm paraphrasing here, but it was something along the lines of, we don't want to work with these particular labs because we know they're, some derogative terms we used at the time, to sort of explain, well, not derogative, but it was like dismissive, right? We know that they are, and I was like, oh, okay. Could you tell me who they are? Because, then at least I know not to go there as well. So there's clearly sort of a whole backdrop to that landscape that you need to be aware of for all these.
And that's our kind of...
Yeah, that's your bread and butter, obviously.
Yeah.
But to my earlier point, clients don't know that. And when they're buying your stuff, there's the danger of giving them too much information that they might not understand, or just say, look, here's the standard, good luck. Those are two different strategies of selling your product.
It's probably not going to be this number and selection of labs that's critical. We take care of that. We do the best we can. Fire assay, it's really common across the world. You're not actually limited by number of labs there.
Yes.
It's more, I suppose, other suites, XRF or the ICPs and things like that, or some of the heated digests or partial digests. One of the big issues that we find is we use commercial labs to certify, essentially. They have tighter tolerances than site labs.
Yes.
So what happens is we go do all this work. We have a certificate with with an uncertainty or a spread, and that spread is based on really tight tolerance labs. You take it to a site lab, they've got different tolerances.
Of course, boom. Yeah.
And
that's what we see as consultants all the time. And then this whole shitstorm starts of, where's gone wrong and what do we do about it? And there's just confusion in that space still.
Right. So you get clients who are actually quite dedicated and knowledgeable about this, and they will have built up over time their own uncertainty models that can apply.
Yeah.
And then there's other people trying to, the square hole, round peg, and so on like that. If we could get further education out in the industry,
that's good, and that's, I guess, part of the thing that we're trying to do through this channel as well, is to speak to people who know how this stuff works, and there's a lot of people in their early careers listening to this who might sitting with some standards for whatever company on the shelf and wondering why the hell they're doing what they're doing, and I, on a daily basis, wonder what the hell it is that I'm doing when I'm dealing, because you just assume stuff, right? Because everybody does what everybody else does, and we will go through this funnel as sheeples, but then, at some point you pick up one of these certificates and you go, wow, I have no idea what goes in these things, right? So that's great. What's next on the list for you guys? What's the next big hurdle or the big target for you guys? Pretty aggressive strategy, or is this just BAU and just trying to do what you do? Or
I think our next strategy, next really big topic is trying to educate people about the crushed gold.
Yeah.
Totally different process for photon assay, because it's a non-destructive test.
Yeah.
It's like, how do you use a CRM? You don't just grab a little 50-gram pack and send it off. It's one shot and go. You've got this material that's reused. And so the process of, like, how do you include that? It just gets rerun and so on. And then photon assay's got its own QC issues that I think people are starting to get their head around now. But it's a new analytical process, and each new analytical process has that like bedding in period.
Yeah.
ICPs had it, XRFs had it, and photon assays going through the same process.
Yeah, but for people listening, you're offering, or you're this is out on the market, right? And you've got your certificates sorted. So there's out on the market there crushed certified reference material specifically focused on photon assaying, and you've got those, and they're certified in I think 3 different. So maybe explain that.
Okay.
Yeah.
Let's go a couple of steps. It's a crushed product. So what it is basically a pulverized CRM. We add some extra material to it to make it a slurry. Then we bake the cake. It becomes a hard cake. You crush it down. When we crush it, there's not a lot of fines that are generated. So what that means is if you've got a pretty equigranular size product, it doesn't actually compact with agitation.
Mm-hmm.
And
big deal.
Photon assay, part of the inputs for analysis is volume. So you need a stable volume. So that's what we've targeted in producing, something that's stable over time physically. So that's the first kind of, the physicals part of it. On the certification side, take a step back. There's multiple ways of doing a certification. You've got the classical kind of multiple laboratory round robin. So we do that for fire assay and photon assay.
All right.
But in addition to that, we certify it during production. So we measure all the inputs that go into it. It's all it's mostly basalt that goes in there, so it's actually a rock. Measure all the gold that goes in there. So we've got a set of certified scales in the lab that we produce it by. So at the end of the day, or end of the process, you've got a product where it all, the circle closes. You know exactly how much is in there.
Yeah, that's
grams
important.
and the kilos that you've produced.
Yeah.
So and you know all the uncertainties on the balances that you've used. So then you can give a concentration and an uncertainty associated with that.
Yeah.
So that's how we've certified it as a check against any other process. So it's independent of the fire assay or the photon assay.
Yeah.
So we've done that as well. They don't exactly correlate, and that's expected.
Yeah, that is expected. Yeah. But seems to be a surprise to quite a lot of people, right? And I think it's becoming clear that, at the end of the day, fire assay is not a total. It's not a total extraction, and the photon assay seems to be sitting slightly higher, and you're actually right. So that's and people have been forever benchmarking everything against the fire assay result, and as the photon assay is now being used, quite frequently. And it's still compared against fire assay, but so it's good to have that certified that way. That you actually know how much gold is in there, and that you don't have to deal with that settling factor as well. So, and our clients, what's the feedback that you're getting from the first round of tests that are coming back? I mean,
okay, we're still processing that data, but we've done a series of tests. How many? 4 or 5 different sites have used it. And so that's both on mining clients and with labs using it. And so putting that data together, it's stable over time. It's stable, it's homogeneous between jars, and so on like that. So it's performing as expected.
Yeah.
But what you're now seeing is an insight into the analytical precision and stability of the process.
Right.
Which is
fascinating. Yeah.
Which is what you want.
That's the point, right? And this is the thing. This is exactly the point. You're doing this to test for the analytical special cause variation, and you can only see that when you have a product that's stable that you're testing. Otherwise, you're just amplifying the noise in which you're trying to find the signal.
You're adding to it, right? So
you're adding to it, yeah.
The whole idea of the reference material is it's more precise than the analytical method. So you can actually measure the analytical method.
That's great. Well, look, that's been fascinating, man. I hope people get a bit out of this. How can they find you? Is it ims.com.au or what's the...
imstandards.com.au.
All right.
It's easy.
I'll put a link in the description, and thanks so much.
Much appreciated.
Yeah,
Thank you, René.
All right.
Yes.